Hello students, welcome to another beautiful math lesson. We're going to be talking about special formulas for factoring. I left off the S here. And so we're going to start with the difference of squares. So just as a quick reminder, remember difference in mathematics we use for subtraction. And squares are numbers that can be evenly square rooted. So like 4, 9, 16, and so on. So the formula for difference of squares is we have some a squared where a represents a real number minus some b squared where b also represents a real number. And the special formula we have says that this is going to be equal to whatever the a is minus b and whatever the a is plus b. And you can see these flips. Sometimes they'll put the a plus b and then the a minus b. Remember, that doesn't matter because multiplication is commutative. So this is our formula. So anytime you're given some difference of square with actual numbers here for a and b, we can factor it by using this formula. So it creates a quick way for us to factor it and get the final answer. So let's go through a couple examples. So example 1, let's factor x squared minus 1. So the first thing is, when you're given a problem, you first have to identify if it's in fact a difference of squares. That's an important portion. So unless you're given an assignment where the only thing you're doing is factoring difference of squares, you want to check it to see what type of factoring you would have. So if we're looking at this to determine if it's a difference of squares, well, we have our subtraction, so we have the difference. Then it has to be a difference of squares. So it's essentially, it should be the subtraction of squares. So we have a subtraction. This first term, well, is this a square? Well, yeah, we have an exponent of 2. Or another way we can say that is x times x, or x is getting squared here. Then the second term, this also needs to be a square, so we need to think about that as well. Well, if we multiply 1 times 1, that's 1. Essentially, this is equal to 1 squared. So 1 is the same thing as 1 squared, or 1 times 1. So yes, we do in fact have a difference of squares, so we can use the formula. So I'm going to write out the formula starting with the original expression x squared minus 1 equals. Then secondly, we're looking for a pattern essentially, because in the formula we have the a squared minus b squared. So we need to find out, okay, what's going to represent our a squared in our problem? Well, that should be pretty easy to see because we have an x squared. So essentially x is our a if we're looking at the pattern. Then secondly, we have a b squared after the subtraction sign. So this b squared is going to represent the 1, or rather the 1 is going to represent the b squared in our actual problem. Okay. Another way we can think about this is if we just set them equal to each other. So the x squared is going to represent the a squared in the formula, and the 1 is going to represent the b squared in the formula. So in order to find our a and our b, to find the factors, well, in order to get the x by itself here, remember the only way we can get rid of this exponent of 2 is this little symbol here called a square root. So we're going to put that symbol around the x squared and the a squared. So the effect that it has is it causes the square to cancel out with the square root, and we're left with whatever's left when we take away the square root and the square. On the right side over here, we're left with whatever is left when we take away the square root in the square, which is a. So the square root is reversing the square. So we're trying to find what number would we multiply by itself to get x squared, that's x. What number would we multiply by itself to get a squared, that would be a times a. So we know our a is going to be x in the formula. We're going to repeat the same with our second term of 1. So again, we're going to take the square root. So be aware that we're not necessarily looking for the exponent of 2. We're just looking for the number to be a possible square. And so we're going to take the square root of both sides. The square root of 1 is 1. The square root of b squared is just b. So now we have found our b in the formula. Now all that's left is that we need to plug those values into the formula. So reviewing the formula once more, the factors will be the a minus the b times the a plus the b. Okay. So here we're going to have the a, which is x, minus the b, which is 1. Then the second one, we're going to have the a, which is x, plus the b, which is 1. So our factors of x squared minus 1 are x minus 1 and x plus 1. Example 2. So for example 2, I want you to factor 4x squared minus 9. So again, we're using... we need to recognize if this is a difference of squares. In fact, well, looking at the first term, so I threw in another number here just so you can see the different ways that you can see a difference of squares. So in this first term here, this should be a perfect square. So we should be able to multiply something by itself to get 4x squared. Well, the 4 itself, that's 2 times 2. And then the x squared is x times x. So our square, so this is in fact the square of 2x here. Then we have our subtraction, so we know it's a difference. Then the 9 here, well, is there a number that we can multiply to get 9? Yes, we can multiply 3 by itself to get 9. So we do have, in fact, a difference of squares. Now we're going to go about writing the formula. Again, we're going to take our first term. That's going to be our a squared. Our second term is going to be our b squared. Then we're going to take the square root of both sides. So the square root of 4x squared, well, the square root of 4 is 2. And then the square root of x is x. The square root of a squared is a. So our a is going to be 2x in our formula. Moving on to the second one, the square root of 9 is 3. And the square root of b squared is b. I'm sorry, I think I said b earlier. The square root of 9 is 3. And the square root of b squared is b, just in case I said it incorrectly. And then finally, we're going to write out our special formula. So our factors of 4x squared minus 9 is 2x minus the 3, and then 2x plus the 3. And these are our factors. Alright, example 3. It's a little blurry. Let's see if I can get it to focus a little bit better. Come on, camera, focus. I hate that it's blurry right now. Come on. There we go. Okay, so feel free to pause the video if you would like to see if you can figure out how to factor it before I do. So working through this example, we want to factor 9x squared minus 81. Again, we want to check that it's a difference of squares. Well, 9 is a perfect square, x squared is a perfect square. We're subtracting, so it's going to be a difference. And then 81 is a perfect square because 9 times 9 is 81. So, looking at our example here, our 9x squared is going to represent the a squared. The 81 is going to represent the b squared. Looking at that pattern, we're going to take the square root of both sides of our equation. The square root of 9 is 3, and the square root of x squared is x. The square root of a squared is a, so our a is going to be 3x. Moving on to the second equation, we're going to take the square root of both sides to get b by itself. The square root of 81 is 9, and the square root of b squared is b. So we have found our a, 3x, and our b is going to be equal to 9. So in our formula, we're going to have, the factors of 9x squared minus 81 are 3x minus 9 and 3x plus 9. So these are our factors. But what I want you to be careful of is when you're looking at your factors, you want to make sure that you've simplified as much as you can, because if not, we say that that is not the complete factor. And so we always want the complete factor or factorization of a difference of squares, or really any polynomial. So there's one more step that we can actually take here, because the 3x and the 9 have common factors. So what is that common factor? Well, 3 times x has a 3 and an x, and 9 has a 3 times a 3. So both of these terms have a 3. So we can factor out a 3, which means divide in this case. If we divide this by 3, we're left with x. If we divide 9 by 3, we're left with 3. And we want to repeat that for the second factor. We're going to get 3 because both terms have 3. If we divide by 3, we're going to be left with x here. 9 divided by 3 is going to leave us with 3. So our final factors here are actually 9 times x minus 3 times x plus 3.